Hi there. Okay, this video is kind of a continuation of the 5.3 note. I'm just going to focus on example number 4. I've already had a couple of people message me about it on Edsby. I just thought that this might kind of help, be a little bit more clear than trying to figure it out by looking at the note. So in 5.3 example number 4, you're given a quadratic relation, okay, in vertex form. And I want to take this opportunity to talk a little bit about vertex form because vertex form can be awesome, but it can also leave a bunch of puzzle pieces unanswered. So what do I mean by that? Vertex form is great because when I'm looking at it, I'm literally staring at the vertex. So the x-coordinate of the vertex is 2.4 in this particular example. Remember, when you're in the brackets, you're being lied to. Take the opposite sign. And the y-coordinate of this vertex is 29. So in the context of this question from the note about a football being kicked into the air, okay, we know that the football reaches its max height after 2.4 seconds, and the max height is 29 meters, okay? So again, vertex form can be awesome. If I'm running a business and I want to maximize my profit, vertex form will allow me to determine, right, how many products I need to sell and what my max profit is. It's fantastic. However, if I am running a business and I want to know my break-even points, I can't get that from vertex form. That's factored form. That's zeros, okay? If I am a coach of some sort of sport, I don't know, there's like a million sports in track and field where you throw stuff. If I want to know when that big disc thing or that big long pole land on the ground, okay, in track and field, vertex form wouldn't help me because it doesn't give me my zeros. So that's kind of what this lesson is about, learning how to take advantage of vertex form to get good information, but then also working around the fact that it doesn't give us all the pieces of the puzzle. So in 4A, it says, what is the max height of the football? Boom. So remember, in previous units, we had to work so hard for the optimum value. We would have had to factor it, set the factors equal to 0, solve for the zeros, add them up, divide by 2, plug them back in. We don't have to do any of that with vertex form. We're literally staring at the optimum value. It's a beautiful thing. Okay, part B says, what time did the football reach its maximum height? Boom. Okay, so easy. Now, obviously, it's going to get more difficult. Sketch a graph that represents the height of the football. So this is a very commonly made mistake. People look here and they assume that's the y-intercept. Folks, we are not looking at standard form. Okay, that was unit 3. We are looking at vertex form. So what do we know? We know that the max height is reached after 2.4 seconds, and the max height is 29. That's kind of all we know, okay? I could find the y-intercept if I sub 0 in for t, and that's what I'm going to do just to determine, approximately make my graph a little bit more accurate. So to find the y-intercept, I let t, in this case, or x, whatever you want to call it, be 0. And we can't let BEDMAS go out the window here. So BEDMAS tells me I have to do what's in the brackets first. Okay, 0 minus 2.4 is negative 2.4. Okay, then BEDMAS tells me I have to do exponents next. Of course, I don't have a calculator. Negative 2.4 squared. So we've got... Then BEDMAS tells me I need to multiply those guys together. And add 29. And this is kind of interesting because I would have foolishly assumed that this football was being kicked from the ground, but it's not. It's being kicked from a height just less than a meter, okay? And I can use that to add to my diagram. When does the football hit the ground? That's what sucks about vertex form, is we don't know the zeros, okay? And then because parabolas are symmetrical, there's another 0 there and we don't know what it is. All right. Now, on a test or quiz or assessment, you don't need to show me all of these steps. I'm just doing it to make sure we reinforce how they're done properly. Okay, the next question says, where is it? When did the football reach a height of 10 meters? Okay, and a very commonly made mistake is kids will throw 10 into there, solve it, okay, and be done with it. That is not how that's done, okay? So we have time and we have, oh my gosh, you guys, again, it's so sorry, or it's so late. We have time. Oh, Nelly, that was a really bad mistake here. And we have height. So let's say 10 meters is there. We want to figure out, okay, when did it reach 10 meters? And it's going to happen twice. It's going to happen once on the way up and then again on the way down because parabolas are symmetrical. So what we're going to do is substitute 10. Oh, scrap paper. Into the equation. And solve for t. Okay, so we're kind of graduating from solving linear equations. This is a little bit more painful. You're going to solve a quadratic equation, but essentially, guys, we're just going to do BEDMAS but backwards. We want to get t by itself, okay? Normally, we would do brackets first. In this case, we're actually going to do brackets last, okay? This guy's got to come over. When he jumps over the equal sign, he becomes negative. Oh, no, he's gone. Okay, that's negative 19. Yes, I cannot believe I'm using a calculator for that. I just really don't want to mess up in a video. Okay. Now, normally, again, we would do brackets, then exponents, then division multiplication. But because we're isolating a variable, we're going to do BEDMAS but backwards. This guy needs to go. This guy's being multiplied by this entire bracket squared. So we're going to divide both sides. And in doing that, these guys cancel. That is exactly what I want. Please be a nice number. Please be a nice number. No. So when I went to go divide this out, it's just a nasty, let's see if you can see it, nasty decimal. On a test or quiz, I would force you to work with fractions to keep it more accurate. But in light of COVID, just go ahead and round to 2 decimal places. So that works out to be 3.88 equals t minus 2.4 squared. Okay, again, we're getting closer. We're trying to isolate t. It's like doing BEDMAS but backwards. So normally we would do brackets first. We're going to do brackets last. This guy's got to go. What is the opposite of something squared? Square root. Okay, so taking the square root of something squared gets rid of the whole square root altogether. Over here, I have the square root of 3.88, which is 1.9, we'll go 2 decimal places, 7, okay? This is where it gets kind of tricky, so pay attention. Okay, so for the person that messaged me on Edsby and didn't understand this, this is for you and everyone else, obviously. When you're taking the square root of a number, you get 2 possible answers, a positive and a negative, and that's because parabolas are symmetrical. And also, this just kind of makes sense. So let's leave this for a second, just so that I can kind of explain that further so you believe me, right? How do I get 25? Well, 25 is equal to 5 times 5, and the square root of 25 is 5. However, 25 is also equal to negative 5 times negative 5. Okay, so you really could say that the square root of 25 could be plus or minus 5. Okay, let's look at 9, right? 9 is equal to 3 times 3, but 9 is also equal to negative 3 times negative 3. So really, you could say that the square root of 9 is plus or minus 3. Okay, that is where this applies here. When you get to the point that you take the square root, you're going to have 2 possible answers, a positive answer and a negative answer. Okay, there's one last step in this process to isolate t. We have to bring this to the other side of the equation. So we have plus or minus 1.97 plus 2.4, right? He's coming over, he's switching signs. Now, okay, we want to come up with our 2 possible answers. So this is where we kind of break it down. T is equal to the positive 1.79 plus 2.4, and t is equal to the negative 1.97 plus 2.4. Okay, and I'm gonna go ahead and calculate away here. Oh, rats. This one goes over here. Jeez Louise. Sorry. Okay, 2 possible answers. Let's go back to our diagram. Okay, so we're saying that the ball reaches a height of 10 after 0.43 seconds. And then it reaches a height of 10 again after 4.37 seconds. Okay, now this exact same process would be used if they had wanted us to find when the ball hits the ground. The only difference is here, the H value, we would be plugging in 0 and follow the exact same process. The numbers would look different, but it would be the exact same process. I believe, did I do that in this note? No, not in this note, but you'll definitely have a question like that in the 5.3 homework. And just to go back here to our diagram, when we use this method to solve for the time that the football hit the ground, you will most likely, or most definitely rather, get a positive answer, but you're also going to get a negative answer because that football was not released from the ground as we solved for when we found the y-intercept. So I hope that helped. I know it's a lot, but you know, you don't have this quiz until Tuesday. There will be a number of multiple choice questions on this quiz, and I'm always available to answer questions on Edsby.